Hi there, my name is Abel. I'm just going to present real quick about the periodic table, more specifically group 6 metals, transition metals of that. I'll start with chromium right here. Chromium is usually found in nature as iron chrome 2 oxide 4. You find it right here, as in this little picture right here. Chromium is widely used in stainless steel and other metal alloys to, stop corrosion and make the metal overall stronger. It's also widely used in chrome plating over for vehicles or all sorts of products, mostly for cosmetics, which I truly don't like. If you were to look at all of these right here, I don't know. I don't like it. And I, I don't think anybody should, honestly. I don't think those should be the road. Either way, um, molybdenum right here. It's also widely used for alloys, again, to increase steel of the metal. But it also has a lot of use in industrial catalysts and enzymes. One example will be nitrogenase in nitrogen fixation. You will find it in nature as this ore right here of molybdenum sulfide. Next, we have tungsten. It's one of the most common and widely known uses of tungsten. It's that it's the little metal filament that it's in your regular household bulbs. Tungsten has a very high melting point, therefore it's used for electricity to go through it and resist the high heat that goes through it. Tungsten carbide, it's also used for cutting tools and heavy machinery, and also radiation shielding for medical settings or X-rays or perhaps any other environment that would expose a person to radiation. This is the ore where you will find tungsten in nature. It's mostly a combination of oxygen with iron and manganese. Now we also have seaborgium. It's a synthetic element completely, so you wouldn't find it ever in nature unless something really messed up is happening. Um, it's only used in scientific research. This would be a picture I got off the internet. Binary compounds. Chromium right here would have a lot of chromic compounds. But before I go into that, just a quick definition: binary compounds are compounds that are made of two different elements. These compounds often consist of metal and non-metal, such as oxygen, sulfur, or any halogen. Here are the examples again. So a lot of chromium is just made with oxygen. A lot of chromium binary compounds are made with oxygen. Um, I wanted to make a highlight right here that chromium 3 and oxygen 3, it's a very powerful oxidizing agent usually used in labs in order to take protons away from other compounds. Molybdenum also has some binary compounds right there with oxygen, similarly to chromium. Again, this one it's used in catalysts and ceramics as well. Tungsten, uh, very common with oxygen. This has to do a lot with the fact that it's group 6. In Seaborg and binary oxides and halides are particularly studied that makes it mirror in W and MO chemistry. Complex compounds. Complex compounds are compounds where a metal is chemically bonded to a charge or neutral ligand. Just a quick refresher on a ligand, which is an atom, a single atom, or a compound of different atoms, or perhaps the same atom, as in a diatomic molecule that has a lone pair that is able to share over to a metal. For example, in this case, like chromium, like chromium for fluoride 6, where fluoride has a lone pair that would share over to chromium, and it's able to spread 6 of them all across the molecule chromium. We can see pretty much the same example all throughout, except for seaborgium. Again, since it's a man-made metal, it's very radioactive and it's very little data out there what we can do with seaborgium. Coordination complexes, we have chromium right here. So coordination complexes are essentially the backbone of a complex compound. All coordination complexes are complex compounds, but complex compounds make up beyond just being a coordination complex. These have specific shapes. So what I wrote right here, I was speaking of in comparison over two complex compounds. Coordination complexes are pretty much the shape, the backbone shape that some complex compound may follow. A coordination complex could be, for example, chromium, um, chromium with a bunch of water molecules surrounding it. But so that'll be the coordination complex. But a complex compound could be that same molecule, but with, in this case, three chloride molecules right next to it, sort of interacting, not necessarily in a sigma bond, but it will be interacting with the molecule. Anyway, we have multiple examples on chromium with water molecules around it, or with amine molecules around it. The same goes for molybdenum right there with cyanide molecules. Combination of 8 molecules of cyanide going around molybdenum. Tungsten, it does the same, but with chloride. And I feel like I'm repeating myself, but seaborgium, right? It's an experimental metal. We don't really know much about it yet. Organometallic compounds. These contain a metal carbon bond, pretty much. That's what makes them special. This allows for a lot of versatility when we're talking about catalysts, because then it helps speed up a lot of the chemical reactions due to the versatility of carbon. We are able to put in a lot of proteins and many other examples. One example that I really like was olefin metastasis. I actually also wrote it right here. Short beans for olefin metastases would be a type of enzyme that allows us to interchange the R groups on an alkene, so a double bond between carbons. As you can see, we just exchange the R chains from both of these molecules. Two chemical highlights. Chromium exhibits a wide range of oxidation states from +2 to +6, making it a textbook example for redox chemistry. While on the other hand, as I mentioned a little earlier ago, tungsten holds the record for the highest melting point of all metals, making it replaceable in high temperature industrial processes. Thank you.